Hey guys, so let's get this dirty. Okay, so we're back. Now we're gonna have our first lab around .NET deobfuscation. Okay, so it's gonna be pretty cool. So let's start. I'm gonna be playing with a binary, .NET binary, which is this guy. Okay, and just quickly checking what we already learned. In data directory, we will have two more directories, .NET, which is what obviously tell us that this is .NET. And since it has these directories, we will have also a .NET directory, which has a lot of information. And here we have the entry point, where it's supposed to be the original entry point. As you remember, .NET has its own original entry point apart from the normal one that comes with the Windows binaries. And here we have all, the meta headers. We have here all our, metadata that we already understood, which is not part of this lab. Okay, so that's just quick overview here. So let's fire up our DNS spy. I'm opening the version of 30 bits because the malware that we are analyzing is 32 bits. As usual, this must be running the VM because it's real malware. Okay guys, so let's load it. We load this guy. Okay, we have it here. We can just quickly inspect it. And one thing that I really wanna encourage you guys is to always check the resources. If there is something there, and if there is something there, then it's high possibility that it's gonna be loaded, right? Why you have something in the resources if you're not gonna be loading it? And that's actually normal in malware. So here we can see that there are many resources, and the size you can see is 186 bytes. And see this guy. This guy is actually 400,000 something bytes, which is, interesting. This looks like a potential binary. And the beauty of DNS spy is that right here, you just do save and you dump it, It's pretty easy. So now we can go to see what's going on inside. And here, as you remember, I have var editor, which is this blue guy. And then I have configured Hue, the demo version. Let me show you how I configure it. If I do F9 and then go to O for options, then go to view editor settings, you can see that here I have my Hue 32 demo, so that every time I do Alt F3, that triggers the Hue for me to have hex edit right away. Okay, so I do Alt F3, enter, and we can see, guys, that this looks pretty much like a Windows binary. However, you can see that here, instead of M, for MC header, is the letter E. We can see, guys, like for example, here it says DAS instead of this. It says program instead of program. It's kind of, here it says EOD instead of mode. Here instead of PE it says X. So it's pretty clear that these guys are kind of changing some way the binary, a little bit of obfuscation. So let's see how that actually works. Okay, so then we go back into the main functions, and here we see that we have this class and we have the main right here, and it has only one line, right? By the way, if you have multiple methods, and sometimes it's not even mentioned as main, you can just go here to the binary, right click and say go to entry point, and it's gonna take you to whatever is the main function, right? Because many times it's not named as main and you might get confused. Okay, so here, guys, we can see that this guy is using the app current domain load, which, if you remember, we understood this function, which is gonna load an assembly in memory. And see here, guys, we have this get types, this invoke member, that, as you remember, we learned it. And now, since we know how reflection works, we know that this guy is gonna load here, and then it's gonna get the class here, and then it's gonna invoke it, with the potential method name, which here is empty, and then it's going to have some parameters which here is empty, right? We will figure that out. And then, as you remember, guys, in our reflection class, we have exactly the same thing. You know, we have a load here, which this is load file. It's just it's different API. That's why we need to know different versions. We have the get type to get the class, and we eventually have the invoke member. And as I told you, we were having here our method name and our arguments, but in this case it's different, okay? But it's exactly the same process. Now we are pretty sure this guy is going to be loading something. So let's see what's going on. I'm going to put a breakpoint here, and then I'm going to say start, okay? In the entry point, okay. So when it tries to run, guys, something very important is when you're dealing with malware, you don't know if the malware was compiled with a .NET version 2, 3, or 4. You know, you don't know. And suddenly, if you don't have that version installed, then Windows is going to prompt you with, you know what, I can download and install that version for you. And when you click here, it's going to do it, and then you can debug it. But many times it fails, and actually for me in Windows 10 it fails. Even though it went through the process to install it and everything, it failed. So I have a workaround which is actually faster and better, and actually works very good for me, where you can tell this binary and the debugger which version to .NET it should use. And since those versions sometimes and most of the time is backward compatible, so you can just use your version. For example, in my case, I have the version 4.0, so I can tell this program to, you know what, man, just use my 4.0. How do you do that? It's pretty easy. So you go to the same directory, and then you're gonna create a file with the same name, like in this case, f8.exe, but with .config at the end. So you create that file, and in the content, what you're gonna put is just this support runtime and your version of .NET that you're using. That's pretty much it in the same directory. And now, now I save it there, and now if we try to debug it again, start, we are working, right? So that's a quick workaround in case you get that error. Okay, so now here, guys, the first thing is going to happen is that this load is going to be executed. If we click highlight here the parentheses, we see that this is the first parameter. Inside this parameter is going to call this function, which is this guy inside here. And following our Carniza methodology, to be honest, I just can go to load here, and I know that load is going to load an assembly, and I just put a breakpoint here, guys, you know, by clicking here, and I dump it, period, move on, right? But, you know, I really want you guys to understand the full process, because it's always good to understand the most important part. And since this is, to be honest, pretty simple and easy, we can go and do the whole exercise for your learning pleasure, okay? So I'm gonna do F11, which is a step into, and F10 is a step over. So I'm gonna do F11, so we get here into the meat, okay? So here, guys, what is gonna happen is that it's gonna get a loop here, and then it's gonna do some execution here. What I did is I actually put this in a file, and I kinda format it a little bit for you guys so that you can understand it better, because there is kind of confusing a little bit. So here is, I think it's better. So here is the loop, okay? The loop is gonna have the first is gonna be the initial start, which is the index. In this case is OBG. Then it's gonna start the start. You know, this is the index, which is gonna be incrementing. This is the starting, which is 0. This is the end, and this is the step, which basically means how many more numbers are you gonna be added to the counter. Sorry, guys, this is the counter. So basically it says, okay, the counter starts in 0, and then the next loop is gonna increment this step, which is 8, and the next one is gonna be 8. So basically you're gonna be incrementing 8 by 8 by 8 in your loop. Okay, this is pretty simple. This one doesn't really matter at this point. And then once you get into the loop, we're gonna call this late index set, which eventually is gonna call these guys. Okay, before going further, just gonna quickly explain you what is new late binding. So basically you have a early binding and late binding in .NET, which basically means is early binding is when you have your classes, methods, and arguments already statically defined in your code, and you compile it, right? And you compile it, that's early binding, because everything is there. The compiler knows about the classes, methods, arguments, and types of arguments, and that's it. But what happens if you are gonna use dynamic calls? You know, you're gonna resolve at runtime classes and methods and arguments. So because of that, you define dynamic arguments, you know, so that the compiler knows that at compile time is gonna be the time when it's gonna realize the classes, methods, and arguments. And that's the reason we have here a late binding. And then we have a late index, which is another function. And basically this makes sense because, as we are seeing, eventually the malware is going to load the assembly in memory, and that's why they are using late binding, which is going to be calculated at runtime. Okay, so now some definition. Late index set is basically going to receive 3 arguments. The first argument is this guy, which I didn't mention it here. Here is easy to see it. Here the first argument is this guy, which you can see is a variable, you know, local variable in the class. And check this guy. This variable is gonna call resource manager, and resource manager, it gets in. Resource manager is basically a API or method to load from resources, and you pass the name and the object, which in this case is exactly the same, but can be different. And we can see here right away that the guy that is gonna be loaded is the resources with that name that we already identify, if you remember, which was this guy, right? Which we dumped before. Okay, so now we confirm that these guys are gonna be loading this guy. Okay, so then that's the first parameter. Okay, basically the late index, it receives, the first is the instance, as you can see, which in this case is the blob object from resources, and then it receives arguments and then argument names. So, but basically what index set is gonna do is gonna receive the instance, which in this case is the object resources, and then it's gonna receive the offset where you wanna overwrite, and then the value. And then basically what's gonna do is, okay, this is the binary, give me the offset and the value that you want me to set there. In other words, it's gonna alter the content of the binary. Okay, now we have here the index get. Index get is the opposite. Instead of setting something inside the blob, it's gonna get something from the blob, and it's exactly the same thing. You know what? I have here the blob of the resources, and now I'm gonna pass an offset, and this offset, I want you to go and grab it and give it to me. Okay, so those are the main ones. So what is gonna happen is that, as you know, we start from all the way here, so we need to go inside. So this is the first thing that is gonna be called. So the first thing is gonna say, okay, from the blob of the resources, you know, get to this offset. This offset, you guys, as you see, is the object, which is the counter, which starts in 0. And then the next one is gonna be 8, and then 16, and so forth, right? So it's basically saying from the raw binary that we got from resources, go to the offset 0 and give it to me. Okay, that is gonna be the first argument which is called the left argument of an XOR, okay? And the right argument of that XOR is a hard-coded 8, which basically means every single byte is gonna be XORed with 8, okay? Once we get that value, we have 1 byte here, which is gonna be the second parameter, the second value of this object. So basically means we have an object with a first value, which is, guess what, guys? Is exactly this guy. Is the offset, okay? And the second argument is the result of the XOR, which makes sense because what is happening here is that it's gonna say, hey, go to the offset 0, give me the value. I'm gonna XOR that value with 8, and now that result, I'm gonna go to the same offset and then override it via index set with the new value. Index set has, again, the binary, then it has the first argument, which is the offset, and then the second argument, which is the value to be set. Okay, that's pretty much it. And then we have a while loop, which is going to be looping all the way this size. So let's see how that works, guys. So we go here, so we do F11, okay, we get into the loop. I don't really want to understand the loop, which I already explained, so I said step out. Now we do F11 again, so we're going to get into the late index get, okay, we go into the late index get, and here we see, guys, what I told you. We have here the instance, which is the blob. You remember this was the one that we loaded from resources. I can do right click, go to show in memory, memory 1, and we can see right here we have that binary that we saw previously. We see here the E, instead of M. We can see the dash instead of this, it's exactly the one we have. Now, the second parameter is the arguments. Let me go back to the locals. And the arguments, guys, you can see here is, guess what? Is the offset, okay? What is the offset? 0, because as you remember, it's gonna be the object, which is receiving, which is 0, and then it's gonna be 8, okay? So then that means, guys, that it's gonna pull the byte at offset 0. If we go to this guy, the value of offset 0 is E, which is in hexadecimal 45, okay? This guy. So which that means is that this function is gonna return 45, okay? So let's do F10 because I don't wanna waste more time there. So now we execute late index get. Now it's gonna call the XOR object. We do F11. We are in the XOR object, and as you remember, the left side is just the value that we got. So let's check the locals. We see the left, and see we have the 45. And in the right side, we have the 8 as expected. As I told you, we will have this late index, which get the offset 0, which is 45, and then that's the left, and the right is always 8, okay? So then here, guys, it's gonna do an XOR, and guess what's gonna be the value that's gonna be resulting? M, right? It should be M because we're expecting an M here because this guy is just converting back, okay? So what we do here is we do debug step out, okay? And then after this call of the XOR, it's gonna call the late index set. So let's do F11 to see what's the result. We go to locals, and you can see here, guys, that it's gonna call late index. It's gonna call the instance. The instance again is the blob, and then we have the arguments. As you remember, guys, the first argument. Let me put it here. The first argument was the offset, and the second argument was the XOR result for late index set. So we see here the first argument is the offset, where it's gonna write back, and the second is the famous 4D as we anticipate, okay? So what I'm gonna do right now is I'm gonna do a step out here, and then I'm gonna come back here and we should have this E updated. So let's do here step out. Okay, and then let's go here. I do a refresh, and we can see that now the M was updated. If I put a breakpoint here, guys, in the while, by double clicking there, and I can run this sometimes, you know, because it's 8 by 8 by 8 by 8. Eventually, we should see that these guys are changing. Let's see it. I do refresh here. You can see that now it's this, now it's program, you know, and now we are getting back in the game. We see the P now is properly. So we got the point, right, guys? These guys are just XORing what byte with 8 those bytes. So we can even do this outside of the debugger. Okay, so then I remove this breakpoint. I just move out into the return because now I know how it works. I do play. So we finish everything, okay? And now we're going with F11 back to where we were. So now we are about to run load because now we already, you know, load everything here, which was the argument, and now it's gonna get into the load, okay? So we get into the load, guys, and here, if I do locals, we can see that this row is the actual guy that it was just deobfuscated. Now, here you have two ways to dump it. I mean, many ways, but two ways that I use. The first one is to right click here and say save. And we can save it as stage1.bin. And that's pretty much it, guys. It's loaded. Let's check it. So we go here, Alt F3. We see that we have there F8, F7, just to see the imports, which is mscore, which is the only DLL loaded in .NET binaries. So everything looks great, which was properly dumped. Okay. Another way for you to dump it is you can do right click here and then do memory show, and then here, guys, is already selected all the chunk of that binary. We do right click here, we do save selection, and then we just save it. Let's save it as 2. Okay, the tricky part here, guys, is that sometimes for some reason it's not being done properly. See, right now, if I go here and I open the second one, see, it gets an error. And you can see it's kind of exactly the same, but the dump is not working properly. Sometimes it works for me, but sometimes as now it's not working properly. So that's why I recommend the first option, guys. Okay, so then now here I do F10 to get out of here, and then I do F11, and the F11, guys, is gonna go and call the get types, right? And the get types, as you remember, guys, is gonna give us the class, right? So let's see what is the class that this guy is gonna be loading, because now that we dump it, we can go directly into that class. Let's imagine that this specific assembly has 30 classes totally obfuscated, and within that class it has many methods, right? We really want to know what it's going to be jumping to. So we do F10 here, it says the module, and when we go here, we get the module, which basically means we got the name of the assembly to be loaded. This DLL.dll, okay? Now let's keep going. And then it's gonna get into this loop, guys. And if you remember, get types is gonna give us all the classes within the assembly, and get type, we can get just the first one. But here looks like is enumerating all the classes, okay? So we do F10, and then we can see here in array, which was already saved, we have 3 values. And we can see, guys, that here is our class that was just read by the program. This is the class that it identified, and this process information and the second one, right? But it's exactly the same name. Okay, so that's the one. Let's see if there is another one. We do F10. It gets out of the loop, so that means it was the only one that it got. Perfect. So we now got we finally got the address. Okay, so then we know now the class. What is next is the invoke member. We do F11, and the invoke member, guys, remember, is gonna give us what is the method that is gonna call. Okay, something interesting to see, guys, here. The name, which is supposed to be the method, is empty. Important to mention that it's empty. That's different from null. Okay, guys, here is a null argument like this, you see here, and this is not null, it's just empty, and you're gonna see the difference in a second. So we do F11 here. Okay, so then we start seeing here some validations, some binding flags. If you remember, when we call this program, the invoke member, we have this parameter, which is just some options on binding flags, which is parsing right here, so we don't care about those, right? So we just keep moving. We jump this validation until, guys, we get to the let me check, it's binder. I don't care about binding. Okay, now here we are. We're in the name, which is the method that we're gonna identify. It says if it is null. You remember I told you that we have the name as empty, not null. That's why it's not gonna get here, because if we would have get there, we get an exception, right? So we do F11, and it says, yeah, you are not null. Okay, now is the length equal 0? Yes, that's different. Yeah, I'm equal 0, and then it says, hey, get default member name. You see, that means that when there is no name on the method, it's gonna get a default one. We do F10, boom, we got here, guys, our method within this class that is gonna be called. We can validate that with our binary. We do open. We just go and grab our binary, which is stage 1. Okay, we got it here. We see that there is the name that we expected, and then when we open it up, we can see that here's our class. And check here, guys, default member, the class that we identified, which, by the way, is right here. That means that as soon as this guy is called the invoke member, it's going to execute this guy. And you can see, guys, here that we have all those different functions. We have this isVM, by the way, which is going to be the first thing. It's going to check if it is running inside a VM. So this is out of scope of this lab. Don't worry, we will have those exercises. But in this lab was just to show you how to do the deobfuscation of .NET. And you can see that we were successful, right? And also, guys, I show you the long way, but following our Carneta methodology, as I told you before, I just put a breakpoint right here because I know the load is going to load the assembly, and I just dump it from here and move on into the next stage, which is the one that we just got. Okay, guys, see you in the next one.